Good afternoon, everyone. On behalf of the ISO, I'd like to welcome you to today's Imbalance Reserves Mosaic Perimeter Results and Summary Stakeholder Session 1. My name is Christina Guimera, representing ISO Stakeholder Affairs, and I will be facilitating today's meeting. Today's slide deck presentation is available on the initiative webpage. You can get to that page by going to kaiso.com, and then under the Stakeholder Center tab on the homepage, you'll see Policy Initiatives. If you click that link, it'll take you to our main initiative landing page where you can search for the initiative webpage. And just a reminder, this meeting is being recorded and the video file will be posted to the initiative webpage for information and convenience purposes only. The recordings and any related transcriptions should not be reprinted without the ISO's permission. If you need any technical assistance at any point during the meeting, please send a chat to Inteller Events or myself. To ask questions during the meeting, you can open the participant and chat panels on the bottom right, and you can then raise your hand by selecting the raise hand icon, or if you joined audio only, please press *3 on your device. And for everyone joining us today, please state your name and affiliation first before speaking, and you can also send comments and questions via chat to all panelists or to me directly. Today's agenda will include an overview on the initiative background, followed by Mosaic parameter testing approach. Afterwards, the team will discuss Mosaic parameter results, followed by scaling methodology for imbalance reserve summary. And after that, the team will give you a summary of imbalance reserves. And lastly, we'll go through an initial STF recommendation. And with that, I'll turn it over to Tobias Steckel to go over the background. And Tobias, you are muted.
Thank you, Christina. I'm Tobias Steckel with the short-term forecasting team here at KAISO. So with that, let's go into the first slide. As part of this day-ahead market enhancement and extended day-ahead market, there will be this new product called the Imbalance Reserve. And with the benefits that come from the Imbalance Reserve design, they may be affected by the underlying performance of Mosaic quantile regression, which is the model that is used to forecast the uncertainty requirement for Imbalance Reserve. Next slide, please. So just going to run through the purpose, plan, and goal then, is that the purpose of this session and the next session will be to initiate an ongoing evaluation of the Imbalance Reserve, specifically the Mosaic quantile regression parameters, because expectations that have been established regarding its performance in the flexible ramp product might diverge regarding Imbalance Reserve. So with that, the forecasting team plans to trial the Mosaic parameter configuration that's initially specified in the external BRS for DAME, as well as alternative configurations, and assess the overall performance. And of course, here we're going to present on the findings and then offer a draft recommendation prior to that work. And then the goal at the end of all of this is that the market participants will get a chance to evaluate and provide comments during this process, and that we will have a optimized set of values to be deployed in the DAME market simulation. So with that, let's go to the next slide. And then this is just running through that same sort of grocery list again, that we want to get a optimal set of Mosaic parameters. We want to provide participants 2 years of simulated requirements with the optimized parameters, and to show the adjusted requirement when we account for the diversity benefit for the participants. And next slide, please. So this schedule is just to help put context into this specific initiative would be prior to the market simulation, and then also distinct and prior to the 5-day configurable parameter tuning process. So this is all happening before that and going to be used as the input into that process. So in November, this call, we're going to be discussing the initial findings, and we're going to be focused on 2 of the parameters that I'll discuss in the next slide. And then this will also be the first sort of indication of the diversity benefit results for the timed implementation entities and then the broader group of participants in this process, because those would provide different numbers as well. So that's the November call. That's the plan for today, and then just highlighting January. And yeah, so just highlighting January is that we'll discuss any follow-up or overflow from this meeting, and then we're going to really focus on data quality and the dynamic and quarterly thresholds. And at the end of the meeting, then we'll kind of assert a final recommendation with respect to this session in the January session and any feedback that we received. So next slide, please. So now I'm just going to put this out there to describe what are the Mosaic parameters that we're discussing. So like I alluded to before, that this will be a shared model with what is being used currently for the flexible ramp product. We call it Mosaic. So I'm guessing most of the attendees should be somewhat familiar with these parameters that we have discussed in the context of flexible ramp products. But the first one that we're going to be discussing today will be the sample scheme, which is basically just the pattern in which you use the training data or historical data. I have a graphical explanation. It's probably a trap for me to try to verbalize this one too much, but the important aspect here is that it's what we call sample scheme 4, which would be the current value that's initially specified in the BRS. And then the second Mosaic parameter that we're going to be discussing today is just the amount of sample days that are used in the historical period. And important to note that this would be initially set at 180. And what we're going to do, I can verbalize this one, is we're going to strip away 1 month worth of data and then also add 1 month worth of data to kind of interrogate those results against each other. And I won't dig too much into the final 3 parameters because, of course, those will be the focus of the January call, but the dynamic thresholds, static thresholds, and then the discard range. So the discard range being that is essentially us imposing this process that we are doing currently for flexible ramp products to identify a more surgical process to identify bad data. So data that's not reflective of the tail, but just truly shouldn't be reflective of the distribution. So if you're interested in those, you got to come to the January call. Then let's go to the next slide, please. So this is the graphical representation. It was a little to describe these as sample scheme 4, sample scheme 7, and sample scheme 9. And you can see if we just first look at the top bar. So this is just showing with reference to any given trade date. So say we're generating for 11/5, is that this timeline that you see on the top is looking a year behind the trade date, 2 years behind the trade date, and then 3 years. And what the colors and then the actual bars below show what sample scheme 4, what data it would be using, and then sample scheme 7 and 9. So this is probably just a good one to keep in mind as we go through the results. And yeah, let's go to the next slide, please. All right, and then I should stop. Is there any questions? That was kind of the background.
Not currently seeing any questions coming through, Tobias.
All right, thank you. So then now we're going to go through the Mosaic parameter testing approach, and this is where I'll put essentially the main caveats here is that as we go through the results, so like I said, there's the different results for the entity that signed the implementation agreement, and then the broader group, which would be all the participants. So as we go through the results, they're mostly going to be reflective of the larger group of participants, and we just anonymized all the BAA names here. So that's why you'll see BAA1, BAA2, et cetera, because we're providing and reaching out to all the individual participants to give you more explicit results. And this should all be considered preliminary and for guidance purposes. And I guess the last caveat here is that it's fairly clear in the discussion that we've had back and forth with the different participants that data quality seems to be a very, very big impactful factor to this. So we've done a lot of iteration and have helped true up some of these issues, but obviously we're still tracking some issues. And so there's that as far as a caveat for how these results look. But yeah, so with that, let's continue on. All right, the testing approach here. And I do see a comment right there when you mentioned 2 years testing timeline. So it's perfect timing. So the testing approach here is we're taking May 2022 to May 2024. This was just due to availability and with the expanded group of participants. So this allowed us to provide this 2 years of continuous data in retrospect, but for a fairly seasonable representation here. So with that, what we did was we chunked it into fixed ensembles. So the first one, we essentially just fixed the amount of sample days, or we fixed all the parameters, and we just looked at the results from sample scheme 4, sample scheme 7, and sample scheme 9. And then next, we ran a second ensemble where we fixed the sample scheme at 4, so the initially specified parameter, but then looked at the results for 150, 180, and then 210 days. Initially, we were going to bundle the third ensemble in here, but we pushed that to the January meeting. Thought it would be more appropriate there. And after running these 2 ensembles, we would evaluate them within the ensemble to see how they did with respect to the baseline parameter. First looking at kind of a period level summary, and if we found that it was an effective or impactful and beneficial change, then what we would do is then kind of further interrogate, what does this look like when we break it down seasonally, or also when we look at our weighted summary. So if we can go to the next slide. This kind of shows you the different approaches here. So starting with the period level summary, and then if we saw that something was beneficial from that perspective, then we provide these other layers to help explain whether or not you should expect that to be a sort of robust result. And the last one here, we have the link included. We will post the slides, make sure people can get this, but this is basically the hierarchical score that we had presented on, which is just a scaled one number where we equally weight all BAA performance. We weight peak time for all BAs more so than all hours, and then look at up and down requirement simultaneously. So that's just another data point that we look at. All right, next slide. And then this is a reference slide to kind of help as we're going to go through this look for both of the ensembles. Essentially, since, like I said before, since we're anonymizing the results, what we're showing you is a comparative change, and we're just looking at coverage and requirement. So broadly speaking, most of the time, if you're in this top left quadrant, that means is that you're able to have the requirement exceed the real uncertainty beyond our threshold. And it's saying that the change from the baseline parameter is leading to more coverage. So most of the time, this is a good thing. And also moving to the left on this graph means that the model, that the requirement is lower generally. So this would imply efficiency and cost savings for the individual entities. And then the flip-flop would be true if you're in the bottom right quadrant. So let's go to the next slide, please. Sorry, yeah, one more. And then this would be when we looked at Ensemble 1. So just for the sake of space and clarity in this meeting, we're just showing the next best option. So from Sample Scheme 4 to Sample Scheme 7, Sample Scheme 9 was kind of thrown out as being not as good as Sample Scheme 7. And what we'll see broadly across these results is that it's kind of a mix of whether or not you're leading to higher requirement or a lower requirement, and also not necessarily increasing coverage in a beneficial way. Because if we look on the right-hand side, that's where you'll see the absolute coverage values. And all of those are already surpassing our 97.5 target. So any increase in coverage here is not necessarily beneficial. So the way that we took this result is it's not an improvement. Any of these sample schemes weren't an improvement from the baseline. So then we just move directly onto Ensemble 2. So next slide, please. Oh yeah, and this is the recommendation then, essentially just saying exactly what I said. The next slide. So now here in Ensemble 2, where we fix Sample Scheme 4, and we're looking at different sample days. So what we find when we take off 1 month from the sample set, so go from 180 to 150, is a fairly beneficial result across all the BAAs, where what we do is about 0.5% to 4% across the different BAAs of less requirement. And when we look at the coverage change, you see it's kind of not really that much of a change in coverage, and any of the results as we look on the absolute value on the far right, we're all above the target amount of coverage. So I guess another way, a couple numbers that I wanted to put out here is that this translates at the EDAM area. So for all the participants, this change would be about 500 gigawatt hours per year of less requirement when we move to this configuration. And the only other thing to add on this is for the sake of intervals in which this happens, intervals in which our requirement may exceed the threshold. So then in that case, the dynamic threshold would kick in. In the base case, that's about 6% of intervals. And when we apply this shorter amount of sample days, then that increases relatively to 8%. So that is one caveat to keep in mind for this change proposed here. So if we go to the next slide, really just, like I said, if we see that, we're seeing that on the period level, or period level summary. So what we wanted to do is kind of understand more of, all right, how does this look in different seasons? And so I'm just showing the seasonal average, and you find is that generally speaking, your lightest dot here, which is 150, as you can see, between fall, spring, and summer, that's where it is carrying that lower requirement on average. And in winter, it ends up being higher, but you see the significant drop in coverage across the BAAs for winter. So this is just one layer of it. And then if we go to the next slide, this would now, when we look at the hierarchical, this sort of holistic scoring approach, what we see is a benefit from the base case 180 to 150 for the Mosaic. In that, this is a golf score, so the lower score would be more positive. So with all that, armed with all of that knowledge, then we can go to the next slide. Then we wanted to look at exactly why this might happen. So the theory behind this is essentially when you using the 210 day to kind of show the the far end of the spectrum here is that the curve that is resulting from the model essentially is it gets too shallow because it has to basically take into account a May day and an October day to describe how this result will happen for a trade date in December. And what I've kind of highlighted is the red dots, which would be essentially December observations. So showing that in this case, the result is allowed to conform a little bit more to the actual month that you're in by taking off that month of trade date. So you don't have the tail end of observations that aren't really I guess, divergent seasonally to where you're at. So that's just the kind of icing on the cake of why we think we're seeing these beneficial results. And then next slide. So this would just be echoing everything that I stepped through, just putting this out there that we will and we are making a draft recommendation to change this parameter from 180 to 150. Then we'll go to the next slide. I believe that's the end of that part of the presentation. So again, I'll stop to see if there are any hands raised or any questions.
currently seeing any questions coming in, Tobias.
Right. Sounds good. And yeah, we did address that other question. So now let's go through, that was kind of the first portion that we're also going to repeat for the January session, where we're talking about actively optimizing the parameters. And this second section here will be showing, I guess, our first indication of these estimates for the imbalance reserve summary. So the first part is that what we want to do, since of course the magnitudes will be divergent across the different participants here, we wanted to find a way to put everyone on an even keel and provide a scaled representation of the results. So just putting in a couple slides here to just show our methodology there. So there's no question marks as to how we got this scaled value. So next slide, please. Using CAISO here, just as an example, is that what we're going to be using for every given requirement, simulated requirement, the hourly level within a given month, we're just going to divide that value by the peak monthly value in that given month. So this graph is just showing what the daily demand peak looks like, and the blue line is what the monthly demand peak looks like. And essentially any requirement that we're simulating within that month is just going to be divided by that blue line for that monthly requirement. And then if you go to the next slide, just to help also show how this looks in a transition from summer to fall, for example. This is just the same thing, just zoomed in a little bit to help show what we're doing here. All right, then with that, let's step into the next slide. So let's go through the imbalance reserve summary. So next slide. All right, this would be the overall results. What I wanted to do is to present essentially this, because it is a shared model. I wanted to first show the similarities, differences between imbalance reserve and FRP. One, the fundamental differences, why they would be different. For example, why this requirement should be higher. And then that's kind of the blue bar, and then the green bar is then how that relates to the actual results that we find. So the main difference here is the uncertainty horizon is just significantly longer, meaning the point in which you have to forecast the uncertainty to is just about an hour, hour and a half to half a day to a day and a half. And then also, so that being one huge difference. And then the second difference, to make sure I get this right, is that the area, so the participating area, and we're going to measure that footprint in megawatts here. So we're just stacking that same monthly peak onto each other. Basically from the participating entities here to what we see in the RSC, that would be like twice as much for all the entities in the RSC. And then how that ends up translating as far as the results that we find. So depending on whether or not we're just looking at the entities that have signed an implementation agreement versus the whole of participation here, that we see the diversity B benefit to be about 25 to 37%, and that's in relation to about 60% of what we see over the same 2-year period for the RSC diversity benefit. And then just another observation is that we find an interesting observation here is that in Imbalance Reserve, we have a peak in the winter for the actual requirement as a peak itself for the EDAM area in winter versus an FRP peaks in the summer. And before I go on further, I see that Robert Fisher has his hand up.
Thanks, Tobias. This is Robert Fisher from NVE Energy, and I apologize. I was trying to keep up. I didn't have a chance to study the slides, but I have a question on slide 22. I'm kind of fascinated with the fact that your study shows you going to a smaller data set. And so I'm trying to understand what you're defining as coverage and how really to interpret this slide a little bit better. I'm having a hard time following it.
Right. I think, and thanks for the question, Robert. I think this was a conversation of whether or not this would be better for supplementary and to really take time to digest. But what is happening specifically here, the point we're trying to get across is that when we take out 1 month of data, we're allowing the model to only look at a set of observations that are just a lot closer to the trade date seasonally. And of course, so this is kind of the Goldilocks conundrum and what we find here is empirically that, like if we get more and more data, it should be generally a positive thing. But when we're including May in the case of trying to develop a requirement for December, then that is maybe more detrimental. And so that's what, so the other thing too is that this is just looking at the first stage. So this, for the sake of clarity, this is just looking at demand uncertainty so that we can show you clearly that it makes sense that you have a demand forecast in hour ending 17 of 22,000. So that's your black line, and it's crossing the curve that the Mosaic came up with at that particular point that I'm highlighting in the red. So that's how you see basically 4,000 to 3,900 to 3,700.
Okay, that does help.
Yeah.
One thing also, you mentioned the word coverage, and I'm trying to look through the previous slides. Can you define that for me? I'm a bit curious what your excuse me, what your definition for that is.
Yes, so our definition of coverage here is when we look over that same, when we look at that 2-year period, it would be the same definition that we have for how we present it in the MPPF. Of course, this is different, but how we do FRP and the MPPF were for basically a 1 or 0 for in the case that your requirement was higher for the up direction than what the realized uncertainty was, then that would be seen as a 1, and then you take, and that's done for every 15-minute period in every hour for this entire simulation period.
Okay, so you're doing it a binary, but what determines if it's higher or lower? What's that measure?
Oh yeah, so we're just what we're showing here, and what the plot is you're fixing and you're only looking at the upward requirement, for example. So if I have 2,000 megawatt requirement and the real uncertainty was 1,000, that would be a 1. And I just take the average of that binary over the whole period. And
Okay.
yeah, so yeah.
So you're measuring the actual uncertainty that you're using is the value that you determined for the actuals. So for say, just for FRP, because I'm more familiar with it, the 5-minute level, final level versus the 5-minute expected forecast versus what the 15-minute forecast was.
Yeah, and in this case, and yeah, this we should add this to the supplementary slides, but yeah, for this case, it's being the day ahead forecast. And in this case, you have your 1 day ahead forecast for your 4 different RTPD forecasts, and this being the T-minus 37.5. So that then we're calling that 4 different unique observations of uncertainty. Yeah.
Okay, thank you. And I apologize for not staying ahead of time, but thank you for answering my questions.
Yeah, and I think we can add, when we go into the next stakeholder presentation, maybe we can add some of those definitions, because I think it is a good question and a good thing to note. We are not looking at the actual that the resources are putting out, because the methodology is using the forecast information. So the observed uncertainty that we measure against in relation to actual, it still has a forecast component to it. So I think we can add what the formula to observed uncertainty is to help. But I always like to think of coverage kind of like a blanket to a degree, right? From the non-mathematical side. Our goal on the upside is to cover 97.5% of the uncertainty that materializes in the observed. And so if you look at how many are out or in, you want 97.5% of them to be in and underneath the blanket, essentially.
Yeah, that's very interesting to me, because I would like to see like the instances where, you know, if we covered 97.5, but maybe only needed 12%. You know, some kind of like, how are we over measuring with the 97.5? Because there's always been that question, and there's a reason of those numbers are in the VPM, is that they could be adjusted if we think that level is too high or too low, kind of thing, right? And so I'd be really, I understand what you're trying to do with the coverage aspect, but I like maybe translate it to like an over procurement of product versus an under procurement type of thing, and where that measure lands, if that makes any sense.
Yeah, it sounds like it's, yeah, I mean, H-score kind of gets there too. And I know that there's the reference materials to take us to H-score, but if there are metrics that you guys do find helpful, there are going to be comments to this. And I think that those would be good to hear from you as we prepare for that next presentation. It sounds like you want to look at, well, if the requirement was 1,000, but my observed uncertainty was 200, it still gets a score of 1. But tell me more about those situations, I think is what I'm hearing in example.
Yeah, I think that would be great too, because like as you have here, you know, you have actual peak demand and those types of things. And as we all know, there's circumstances where we don't need that full requirement. So kind of that balance of those things would be kind of an interesting component to that. And these questions or these answers are great. I can use this to understand this methodology more, and I may just fully agree. But thank you for taking the time to answer my questions.
Okay, I'll pass it back to Tobias. I don't know if you want to expand on H-score at all, or see if there's any other questions.
Right. Yeah. I was just going to say, I think it seemed like that might have been a hybrid of 2 things. One, the percentile itself, which is going to be discussed in the in the DAME configurable parameters working group as just an additional plug. And then the second one is, yeah, I think there was a little bit of the discussion of efficiency and the way, I guess, that I think Alicia has shown slides, like graphically, there is such a thing as, you know, you can have the perfect requirement here that is essentially just the same as your uncertainty all the time. And of course, that is the extremely, extremely high bar that we're probably never going to get, but we're going to keep striving toward. But I think, yeah, with the H score is to try to bring in some more of those efficiency metrics, because that's, of course, that's the huge gain that we see and we can pursue through this like regression or any methodology beyond just the histogram, because the histogram is always, when you set a percentile, and let's just say this percentile is fixed, that any like sort of histogram type approach is always just going, it's always going to be super high. So we hope with this, like the result that we're showing before, that this change would carry a lesser requirement, but still achieve that coverage we want. But when we look at that versus histogram, the benefits actually then multiply by 5 as far as the efficiency savings. But yeah, yeah.
One other quick question about this diversity benefit. You can see it's pretty much half of the FRP. Is that because you only have a few areas? That was my speculation, but.
Yeah. So this would, I'd say essentially when you look at the area peak demand, that's like pretty much gives you an approximation of the size difference of the EDAM area versus the EIM area. So yeah, it's about half. That's what we see area-wise. It would be about half, and then the diversity benefit ends up being, around that.
So that means to me that the summation of all the areas is much larger than the EIM area assumption, then, right?
This would be, sorry, so basically when you have all the participating megawatts here, that's 89,000. And then when you look at all of WEIM, so using that as the example, that's 160,000. So it would be about, the WEIM is about twice as big as the EDAM area that we're looking at here.
Okay, I got that.
Yeah, and I just want to add, I mean, there is an asterisk there that talks about the caution. We wanted to show the diversity benefit, and we know that we get questions in relation to how it compares to FRP, right? Because I think that's what everybody's most familiar with. And we were okay putting them on the same slide together, but I just want to put a lot of caution out there, right? They're different time frames, they're different granularities, they're different footprint sizes, and so it's not it shouldn't be a straight comparison. This is more of a reference point for you guys to just kind of see what it will look like as IR comes into picture. And then of course it will change depending on the entities that are joining, and as well as the forecasts, right? And how those forecasts evolve from a day ahead to an FMM perspective that are there too. So I just want to put that caution out there. There is an asterisk third down on the list, but it is still really important to highlight that.
And what's the footprint for this IR? Is it just PAC and CAISO?
So the bookends, the 37%, that would be for all the participating BAs in this process.
And I do see VJ's had his hand up for a bit too. So I don't know if there's any further questions that you have, Robert.
No, I'm good. Yep, good.
Okay.
Yeah, thanks. This is VJ from Pacific Ore. Thanks to Maya for this presentation. A lot of really useful information, and yeah, just super interesting. Just had one question. So are you considering at all testing for sampling days less than 150, or you're kind of just interested in going as low as 150 sampling days for that sampling scheme number 4?
Yeah, I think the initial plan was the initial plan wasn't to from I guess preliminarily we looked at it that 150 would be like a bit of the bottom. I don't think we would want to go to 120. I think then we kind of lose that. Then we just have too little sample data. So I think the plan is to retain that and not assess going lower, and then imposing the next round of parameters on there. At least that's for this process. And I think as, yeah, so that's how I respond to that question.
Okay, yeah, that makes sense. Thanks.
I'm not seeing any further questions, Tobias.
All right. Well, yes, thank you for the participation. I'll try to round out the next couple of slides here. So the implied last row that would be on this is what does this actual requirement look like? Like I said before, we wanted to scale this representation so we can kind of show the even keel of all the different participating BAs. So if we go to the next slide, please. What you see, so I'm just gonna, for the sake of simplicity, you have up and down, but I'll just talk about the up numbers here. So for the different 7 BAs, that when we just look at the scaled, remember scaled to the monthly demand forecast, the scaled requirement is about 7 to 11%. And when we apply the diversity benefit, we get an effective requirement of about 5 to 8%. And then just for the sake of consistency with the last slide, this is with respect to FRP, that unadjusted value is about 2 to 4%. So that's kind of what we see as far as magnitudes for this high level. This is the 2-year summary, and just an anecdote something that we're going to continue looking at, because what we want to do, part of this process too, is to identify factors that are really contributing positively or negatively to this. And one thing that we find is, of course, MAPE or accuracy, even though this is explicitly percentile based, trying to get that 97.5, what we can see in most of this is just an artifact of the data quality, is that the entities where we saw an increased bias or increased error from the day ahead to the RTPD timeframe, I mean, that kind of directly manifests here as a higher requirement. So that's one thing, and in our individual meetings, we'll definitely talk about that and try to parse out what's coming from data quality, et cetera. And so that's the first big takeaway here. And then the second aspect here is that we did see an increased correlation between wind penetration. So how much wind generation you have is kind of scaled against your demand forecast. So that was also found to be a positive contributor to as in increasing your requirement. So that was two observations that we wanted to kind of just say at a high level, and of course, in individual discussions, we can talk about that more. And then let's go to the next slide. So then just gonna kind of round this out, is that to summarize what we went through, we are making this draft recommendation to retain the same sample scheme 4, and then we're recommending to switch the amount of sample days because it provided a more efficient outcome. So there's that recommendation, and then just kind of reiterating some general observations that have been scattered throughout this presentation, but generally speaking, we do see that this balance reserve is overcovered versus FRP, which is generally a little bit undercovered of what we've seen empirically. And there seems to be a correlation between wind penetration and increased requirement magnitude, and that the EDAM area, the upward requirement, peaks in the wintertime. So I think that was my last slide, and then we have one more slide to kind of open up with any more questions or suggestions, different approaches. So this is your time.
Not currently seeing any questions coming in, Tobias. Do you have any final thoughts before I take over?
I guess not. I will be in contact about setting up this meeting and providing data to the individual participants, and just want to say thank you again. Hopefully this proves to be a mutually beneficial thing for everyone. So yeah, thanks for the coordination. Yeah, that's all I have.
Yeah, I just want to second that, as well as there will be comments available for you, and I know Christina will go through that, but it is a lot of data that had to go into this analysis, and there really was a partnership between the entities that provided that data to Tobias to get to this spot. So thank you guys for all that effort and cleaning the data, scrubbing the data. I'm sure there'll be more of that going on before we get ready for go live, but really appreciate the collaboration.
Thank you both so much. Now I just have a quick announcement before we close out here. For insights into the ISO grid and market operations, please be on the lookout for our Energy Matters blog. Here you can see our latest blog posts on GHG and AI. And with that, we'd like to thank you so much for joining today's discussion. As a reminder, this meeting was recorded for information and convenience purposes only. The video file will be posted on the initiative webpage. We thank you very much, and we hope you have a wonderful rest of your day. Thank you.